European PV markets have taken somewhat of a battering in recent years, but it still remains a location for a great deal of solar innovation and also attracting high quality and high powered solar components. My name's Jonathan Gifford, I'm the editor-in-chief of PV Magazine Global, and here at the 2017 Intersolar Europe in Munich, we're going to meet some of the suppliers of these high powered modules and also learn about the enabling technologies.
Well, ultimately, efficiency is driving, and it's the main driving force to lower LCOE, because it impacts not only the modules and the energy that you produce, but it impacts basically all the rest of the system. And Trina is really focused in developing high efficiency product, although we keep a very large portfolio of product from the basic multicrystalline simple cells at low cost to the most efficient, and we're developing very high efficiency solar cells like our RESi program, reaching more than 24% on 6-inch substrate, which is a world record on 6-inch.
Max Schurada is from Hanwha Q-Cell's R&D department. Hanwha Q-Cells is showing its new steel frame module, 72 cells with an output of 375 watts. It picked up an Intersolar award here. Now, we've talked a lot about cell innovation and cell technology, but really the steel frame module is about innovation on the module level. Firstly, the name steel frame, what's the significance of using steel rather than aluminium?
Yeah, you are able to reduce the CO2 carbon, so the carbon footprint with this significantly. And we also developed a smart installation system for it, which enables us to install it in around 50% of the time. So the time saving is very important there for the installers to also save costs. And then you just need screws to fix it, and that's it. So you can be really, really fast. Nobody has to hold the module during the installation. But this is really a big advantage from our perspective.
And also to achieve the high power output, there's also been some developments that you've deployed in terms of the junction box and the cabling. Can you tell me what's happening there?
Yes, we are using a split junction box for this module. That means in total there are 3 junction boxes, and 2 of them have a connector. So it comes without a cable, and the customer is able to select the cable length he wants to use for his project. And therefore you can reduce the serial resistance in the system, and that increases the power, obviously.
These kind of high efficiency and high output solutions, what's the demand like from Europe when you're speaking to installers? Price is always a major factor. How does that play out with performance?
Yeah, price is always very important. For us, we try to offer our high power products for an affordable price, which is important, and we are able to do that by using our quantum technology, which is based on PERC technology but with some special features.
Andrea Viaro is the head of technical service for Jinko Solar in Europe. Andrea, what's the role of high efficiency modules in the European marketplace?
Well, at Jinko Solar, we always focus to boost the power of the solar modules that we produce. We are focusing now, for example, on the half-cut cell mono-PERC technology. With this module on 60 cell base, you can reach 320 watts peak on a single module.
Okay, well, Europe is in particular not a place where land prices are particularly low, neither is labor throughout the continent. What kind of role can modules play in reducing installation costs?
It's very important to reduce the LCOE and the production cost and the cost of the installation, overall cost of installation. So for this reason, we also developed the technology with Maxim for the optimized modules. It's a new technology based on integrated circuit. We optimize modules at the substring cell level. So it's the best technology in terms of optimization of solar modules that you can find in the market right now.
Okay, Andrea, as I understand it, both the Maxim integrated and the half-cut cell module use mono-PERC. What kind of momentum is behind mono-PERC in the market at the moment?
There is a huge push from China on mono-PERC because of the programs that we have in China, boosting efficiency of modules. So we are putting a lot of efforts and investments on mono-PERC technology. Our production capacity right now is still focused on polycrystalline, but we are increasing more and more the production capacity for mono-PERC.
monocrystalline PERC is certainly one technology pathway that manufacturers can proceed down on the journey to high efficiencies, but that's not to say multi-PERC should be forgotten. Since Q1 2015, Singapore's RESi has been producing multi-PERC technology at their fab. Chem Saber is the head of product management and global marketing for RESi. Why is it that RESi has this confidence in multi-PERC technology?
As RESi, we've had confidence in the technology since our very, very start. We have believed in the multi-technology since many years, and we have invested a lot of R&D dollars in making sure that we can prolong the life of multi. Back in 2012, we had panels made with multi-technology which were giving about 250 watt peak per module on a 60 cell. At that time, people thought that 260, 270 was maybe the maximum we could get out of multi-technology. Today, with our latest 60 cell products, we're able to reach 295 watt peak on Twin Peak 2, and on 72 cell product, which we can see here on the right, we've been able to reach 350 watt peak. It's been received very, very well. It has to be said that the 72 cell market in Europe is smaller than, for example, in the US. In the US, 72 cell products are used in utility scale ground mount systems, but they're also used on CNI, so commercial and industrial rooftops. So we have great confidence that we can compete with other technologies which are out there with our 350 watt peak, because other competitors of ours are easily using mono or mono-PERC technology to reach the same watt class.
Well, and actually beyond simply the cell technology, there's also a number of module level innovations that the Twin Peak deploys to achieve high output and high efficiency, high performance. Can you just talk me through those quickly?
Absolutely. I mean, one of the things I'd like to talk about here is the Twin Peak module is actually two modules, top, bottom, which are connected in parallel. So, for example, one of the big advantages of Twin Peak, if it's mounted in portrait mode, and if there is shading on the top, the bottom part still produces power. If it's shaded on the top, in the other way around, it produces power on the top also. So it is quite interesting from that point of view.
And how's that achieved?
That is achieved by making sure that, from a technical point of view, the top and the bottom part of the modules are actually separated, electrically speaking, and they're connected in the middle. So what you have is a current voltage which is the same as any other module, but it is still, electrically speaking, two separate modules. That's why it's called Twin Peak, because twin is our half-cut cell technology, but it's also the way the module is built.